Alrighty, we're back. So what we're going to do now is part 3 of question 2, and we're going to implement our logical circuit here in assembly. So as it says, write a small arm assembly program to calculate the value of the bond wire, or the output of the circuit, and store it in register 4. Now we're using registers 0 through to register 3 as our input wires, R0, R1, R2, R3. So R3 is the third bit, R0 is the 0th bit, and so on and so forth. Okay, so let's have a look at this. So we're going to essentially represent each gate as an instruction, and we'll use a few registers for our intermediate steps here. Alright, so let's switch to our Visual Studio Code. Actually, I might see if I can do these side by side. Okay, wonderful. So let's do our OR first. OR instruction, nice and simple. I'll use register 5 as our intermediate step here. So we'll have OR of R5 with R0 here and R2. Okay. Now because we're only using the lowest bit of each register, we don't have to worry about anything above our 0th bit. Nothing else. Okay. So we've ORed our 0th and 2nd bit, and we've put it in a intermediate register. Let's do the same thing for our NAND over here. Now what we could do is say not R1 and then NAND that with R3. But there's a cheekier way that we can do this. So if we go into our cheat sheet here and look at the bit clear instruction, bit clear is an AND where one of the inputs is knotted. So it's AND RN, not RM. That's what this little symbol here means. That's a NOT. So we can actually remove an instruction here by saying BIC R3 and R1, and we'll put this in register 6. So what this will be is R6 equals R3 and not R1. So if you look on the cheat sheet here, RN and not RM, well here we have R3 and not R1, and we're putting the result in register 6. Okay, so that saves us 1 there, but unfortunately this is a not AND, so we still do have to not it. Now in ARM we don't actually have a not instruction, but if you're a particularly clever clog, you might be able to work out that this will do a not. So if you're wondering how this works, write out a truth table for exclusive OR where one of the inputs is fixed to 1, and then have the other input, 0 or 1, and see what it does. And you'll find that if we XOR with 1, then we have the equivalent of a NOT. Okay, so our final gate up here is a NOT OR. So I don't believe we have an instruction for that either. Nope, we don't have a NOT OR instruction. That's okay. So what we're going to do, same thing. Now, the question asks us to write our output to R4. So we'll say OR R4, R5 and R6. So remembering that R5 was the output from this gate here, and R6 was the output from this gate here. So we've ORed them together, and now we'll EOR that, exclusive OR with 1 again, and now we're done. So by the time we get to, let's put an end in here. By the time we get to the end of our program, we should have calculated the bond wire. Okay, so let's get this back to full screen, and let's run the debugger and see if we've done the right thing. So we know from before what, well, at least a few combinations that should give us a kaboom, and a few that should give us a not kaboom. So let's find out. I'll put a breakpoint down here. Actually, let's just step through this. Okay, so we'll settle our registers. Right, you are. Cool. So we do our OR here into R5. OR of 1 and 1 is 1. We do our BIC, which is our AND with one of the inputs knotted. That should give us a 0, I believe. Yep. And we'll knot that. Now we'll OR the two together, R5 and R6, giving us a 1. And then we'll knot that again, and we get a 0. Right, cool. So we know from the previous video that if we have all 1s, the bomb doesn't explode. Now I think the first input combination that made the bomb explode was this. So let's give this a go. So we have 1 in bit 3 and 0 in all the other bits. Okay, so we'll debug, we'll move them all in, and then we'll step through. So OR of 0 and 0 is 0. Our BIC or NAND with an input nodded, what's that going to result in? That'll result in a 1, and then we NOT it to get the 0, and we OR, and both the inputs of that OR was 0, so the output is 0, and then we NOT that, and we get a 1 in R4, which means our bomb has exploded. Congratulations, we've written the program in assembly. So we can change any of the bomb inputs by just changing these mobs to be a 0 or a 1, if you want to try it at home. So yeah, that concludes this video. Thank you.